talk about atmospheric circulation a little more. We talked about the idea of Coriolis effect, how things kind of get skewed around a little bit. Let's just go over some real basic stuff when it comes to weather and make sure we're all kind of thinking along the same lines here. Everybody knows hot air rises, cold air sinks, right? It's kind of one of the basics. Well, what's really going on when that happens? And if we look at it, as air comes in contact with the land is warming the air up. So the volume's expanding. And if volume's expanding, that means density is decreasing, right? Volume's in the denominator. So air starts to rise. And as it starts to rise and expand, it's going to start to cool. Partly because it's expanding, so bigger volume with the same amount of energy. And it's getting away from the land, which is where that infrared heat is radiating off. And, you know, we've all kind of experienced this, walking up a mountain during you know, kind of a hike in the afternoon, and you start out in the valley, and you're nice and warm, it's a beautiful day, and by the time you get to the top of the mountain, you're pretty chilly, and you're glad you took your light jacket along with you. Then as you walk back to the valley, it's warm again. It's not that there was a big temperature fluctuation during the day, it was simply an altitude change as you went up on the hill. Now, as air cools, it's going to start to become denser. So even though this air has been expanding and cooling as it rises, eventually it's going to cool to the point where it's going to become dense again and it's going to start to sink back to the earth. Now, as it does that, you can think in terms of, well, it's sinking lower, so now there's more air on top of that air, and that means it's going to get compressed. It's got more weight of other air on top of it. And as it sinks, it's going to get more and more weight, so it's being compressed. And think about when you pump up your bicycle tire, and you touch the hose from the pump to the tire, and that hose is getting hot. You're compressing that air, and it's getting hotter, right? Temperature, pressure, directly proportional. Pressure goes up, temperature goes up. So as it comes back to Earth, just this compressive effect is warming it up, plus it's getting back toward its heat source here at the surface of Earth. Okay, so that kind of gets things moving up and down. The other part of this is moisture. And when you put moisture into the air, it turns out that air can hold moisture up until just a certain point, and that's it. It gets saturated, the air is saturated, it can't hold any more water vapor. It turns out that warm air, because it's expanded in volume, can hold more moisture than cold air. So let's say I have air at 70 degrees, it's 100% saturated with all the moisture that it can hold, and the temperature starts to drop. What's going to happen to all that moisture? Well, the air can't hold it. It's going to have to start coming out of the system. And it does. It starts coming out as dew. It'll start to form a coating of moisture on blades of grass, on twigs. It nucleates the moisture, the vapor, and we start to see dew form. And as the temperature continues to drop rapidly, it forms water droplets and it begins to rain. I mean, it's kind of extreme dew point, right? So this point where we see the water start coming out of the system, that's the dew point. That's the temperature at which anything that's where the air is 100% saturated. And any temperature below that, we're going to see that moisture start to come out of the system. So just the simple fact that air is rising, and as it's doing that, it's cooling, it means that the moisture that the air can hold is decreasing, right? It's called adiabatic cooling. And we're going to start to see, simply because the air is rising, we're going to start to see moisture come out of the system, eventually. It also means that dry air coming down, compressing, and warming is now going to have the ability to pick up more moisture. So Here, moisture is going to be coming out of the system in the form of dew and rain as that warm air lifts and hits the dew point. Here, cool, dry air coming down is going to hit the land and be able to pick moisture up and carry it away. So those are a couple of important things going on here. So I guess the question becomes now, what's heavier? What's denser? Dry air or moist air? And if I were to ask you this on, say, a 100-degree day in August, and it's just kind of one of those muggy, hot dog days of August, I think you'd immediately say, oh man, this air is just oppressive, it's heavy, it's hot. But let's look at air. If I look at just the oxygen component in the air, and I look at oxygen, it's right here, atomic number 8, and it has an atomic mass of 16. And remember, oxygen in the air, it doesn't just stay as an oxygen atom, because that's very, very reactive. It's going to latch onto anything. And up there, the thing that's going to be the most plentiful is other oxygen atoms. So it's going to jump on another oxygen atom, form a covalent bond, a good strong bond, and we're going to see this as O2, 2 atoms of oxygen making up a molecule. So that means I'm going to have an atomic mass of that molecule, O2, it's going to be 16 plus 16, it's going to be 32. That's an oxygen molecule up there. Now, if I were to take that oxygen molecule and replace it with a water molecule, water moisture, H2O, well, it's going to be an oxygen of 16 mass. It's going to have 2 hydrogens, each with atomic mass of 1. So that's a total of an atomic mass of 18.